Okay, so we'll be talking about Vibrocast, the revolution in precast. But before I delve into this topic further, what I would like you to is to look at this screen and ask and answer these questions for yourself, whether you want to produce these things that you often use in your infrastructure projects faster and without the mess usually associated with it. Coming to Vibrocast, Vibrocast is a machine, is a technology for vibroforming of small or specialized precast elements. These machines are designed to uh, change from one element to the other element in less than 20 minutes. So how does it work? These are easy to use, reliable machines which are operated by one person and with the help of another person to load the machine with concrete. These machines are designed for efficiencies and they're built to last. Efficiency means greater production with lower costs and consequently greater profits, not just for the company producing them, but also for all the stakeholders in general. So that is, so we have been talking about sustainability all this morning, and sustainability is basically all the stakeholders have sustainability one of the key factors for them. So if it is profitable, it means it is profitable as sustainable also. So what is the vibroforming technology? It's basically, we have all done these shapes, molds on seaside. So you form with sand these peculiar shapes using some molds, right? The water to sand ratio is critical in finding the right product, with the right shape being delivered to you or being produced. The same way, water to cement ratio comes into play for vibroforming the elements. We all know this, most of us are civil engineers here, so we all know this water to cement ratio curves, wherein the lower the water content, the higher the strength that you are able to achieve from the product that you are creating from the concrete. Now, coming to the advantages of Vibrocast technology, it is high productivity. You reduce your manpower from hundreds of people working on the site to just 2 or 3 people managing the whole show. You have fast change of production, which I said that you can change from one mold, one design to the other in less than 20 minutes. You require much lesser area. I'll touch upon that. Versatile with safety, because the less amount of molds we are handling means the more safer the production is. Low investment. It can have tailor-made molds and, as I mentioned again before, high mechanical strength. Because you are forming with a dry kind of a concrete, it's a zero slump kind of a concrete, so you're able to achieve higher mechanical strength for this. So what is the difference between wet cast, which we are traditionally doing, and Vibrocast? Wet cast means long production times, right? You're talking about lack of consistent, because we need a lot of manpower. This morning also, the Ramanna sir, he touched upon the lack of availability of skilled manpower in the industry. We all know about it. High number of, so we need a lot of people to do this. We need all the individual molds. We need to have hundreds of molds on the site, and all those molds have to be cleaned at every cycle and oiled and everything, so forth and so forth. You have lesser mechanical strength because you have more water to cement ratio. So because to make it more workable for the wet cast process. Whereas when you come to Vibrocast, you have rapid production of elements. You require just a few handful of personnel doing the job, and it's easy to maintain, is mobile, so you can produce wherever and whenever you want. Just a little bit upon what is the conventional cycle. We'll just to rekindle what we are doing currently. You will have the preparation area with all the molds. You'll have to clean that area where you'll keep the molds together. You have a mold storage area. You prepare the molds. You have the different small elements which are for example, some holes in the element that you have to produce, or some lifting hooks that you have to produce. You'll have all those separate elements to be inserted in the mold. Then you fill and vibrate each mold separately, and then you lay it there for hours, maybe days, before you take out the mold and demold and get the element ready for use. And what does it all translate into? A lot of space required for all of doing this. You have this stacks of molds across your casting yards. We've been through all the major casting yards, and you'll have these stacks of molds, people preparing molds, welders and everybody doing all the kind of jobs to get this done. Whereas with Vibrocast, you just need a clean slate floor. That's it. You just need a flat slab. You bring in your machine, which is mobile, and you have a concrete delivery system. Could be a forklift, could be a hydra, or whatever it be. You just have these two in place, and then you start producing the product. Every 10 minutes or less than 10 minutes, you can have elements ready for use to be delivered on the site. So this is the small, simple vibroforming machine, Vibrocast, that we talked about. You get the concrete, you fill in the concrete, the machine vibrates the concrete automatically, settles the concrete. See how the concrete is settling in. You can have, once the concrete is settled in, within few minutes, the machine will flip it over like this, and bam, your element is taken out from the machine within minutes. And you don't need multiple molds. One mold is enough for producing whatever you want to produce. I mean, whatever quantity you want to produce. You see the bunch of products that you're able to achieve through this. So, no more stacks of molds. No more messy sites. High mobility with high productivity. So these are some examples like box culverts. You can produce 100 meters of box culverts every day. 100 meters. So if you're saying, I want to produce 1 kilometer of road, I probably need 2 kilometers of box culverts. In 20 days, you have 1 kilometer ready for you, and without massive space required for doing that. Telecommunication walls, catch basins, your rings, your manhole risers, your hawk slats, you name it, and you can produce it. Your U-drains, channels, your manhole covers, whatever you want. I mean, you can produce it so quickly. The crash barriers, New Jersey barriers. Every day you can produce 600 meters of these barriers. Doing a kilometer of a road means in less than 2 days, you have the barriers already in place. Doing 60 kilometers of the road, you have in few days, less than 100, in just about 100 days, you have all the 60-kilometer road barriers in place for you. You want to create smaller barriers that you want to segregate the pedestrian traffic, which is a major challenge that we cities are facing. The pedestrian traffic is not segregated from the cars, which makes the roads unsafe. You want to quickly create that separation between the pedestrian traffic and the car. You can do it with this. Have these things in place far easier, far faster than anything else. So at the surveys of infrastructure, public works, and much more. But now, how we are able to do it? This Emer is a more than 65-year-old company delving into innovation for talking with the clients, understanding their pain points, and delivering more than 1,000 projects in concrete space worldwide. I'll take this opportunity to introduce some other products that we have as a range, as a company. As Speedcast is a casting truck. So this is for wet casting systems. Instead of employing, you are doing on-site precasting. A lot of people do that, and a lot of infrastructure projects. Instead of installing all the big, overhead cranes, gantry cranes, you get this truck that moves quickly, brings the concrete from the plant, and pour it in the molds. So it does bringing the concrete, logistics, as well as pouring. aerial platforms, different kind of aerial platforms, different kind of mortar pumps, spraying machine for housing projects or your building projects, commercial projects. So our view, our target is 360-degree customer view. We are in Italy and worldwide with all the tools built in, whether it is Industry 5.0 or your managing softwares, and everything is there. So that's it from me, my friends. We are here for you. My name is Rajiv Singal once again, and we have the Italian product manager as well available for you whenever you want. We can, we are ready for discussions, and we are open for questions. Yes, if any.
So how you put the reinforcement? So on that you've shown. So how you put the reinforcement inside that? Yeah.
Like you insert reinforcement in your traditional molds, you'll be inserting reinforcement in these molds before you insert your concrete, before you fill them with concrete.
Video you have shown. So what my understanding is, there could be a two ways. One is that you just pour the concrete, and from the reinforcement it can go down. By seeing the concrete, I don't think so that it will be a self.
No. It's not a self. It is a dry concrete. Yes.
It's a dry concrete. So compaction or some kind of a extrusion technology. I feel that.
Yes, it's a vibroforming technologies. Let me try to replay this video if I can. So before you pour the concrete in these molds, before this process, you're actually placing the reinforcement inside these molds.
But if my reinforcement is, my reinforcement is not in the bottom.
No.
Could be in there.
Oh yes, all around.
Concrete can go in such a small.
Yes. This one. Yeah. So you see in the bottom left, in the top picture in the bottom left, you have the reinforcement there. That will be placed in this mold before it is cast, and you get the slats.
Okay. But for slab, I can understand. For that
yes,
kind of a thing,
same thing applies. Same thing applies.
Okay.
Yeah.
Thank you.
What is the operational cost for all such kind of things, and how do you, if in any case any machinery problem is there, so how your team comes up to that? I mean, if it is in far location.
Two questions that you've asked in one go. One is the operational cost. So the operation costs are very low, and that's the reason why we are talking about this. When you are this machine gives you the benefits of modular production in an in situ conditions. So you can produce on site without having to have large investment in the plant and machinery sheds. Now, how does that help operationally? Your logistics costs, exactly, and you're producing low value elements. These are not high technology elements, high tech elements. So your cost of production, the cost of operations must be low enough to make them more profitable, and that's the reason why we are saying this. Number one. Number two, because there is only one mold, you don't need hundreds of molds. You don't need to maintain those molds. There's just one mold. So your maintenance costs, your cost of stocking those molds, all of that is eliminated, because this is just one single mold that keeps on producing the elements over and over for years and years to come. Now, on the aspect that you asked regarding the how we are able to solve problems on site, because as you rightly pointed, some of these machines are in remote locations, as remote as Siachen. So, obviously to reach there, it will take days sometimes in some of these locations. But thanks to the beauty of that Industry 5.0 that I just mentioned about, thanks to the beauty of technology that we have in place for us in these days, we are able to resolve majority of the problems within few hours. You just make a small video call. This is available now thanks to all the initiatives, the digital initiatives that governments have taken across the last decade or so. You can make a video call with anybody at any place, and within few, these machines are very simple. There's not much of electronics going in there. They're more mechanical and electrical kind of system. So it's very easy to repair if something comes up. Usually it does done. Yeah. I hope I've been able to answer your question. Thank you.
I just have one question. In how many days, once the drawings are all clear, this can be made available, any mold?
Okay, so it usually takes about a month to get the mold ready, because it's when you send us a drawing, we analyze the drawings from the mold's perspective, because there are a lot of mechanical elements inside this mold. It is not just that you are putting small things going in. There are a lot of hydraulic and mechanical elements inside these molds. So we have to design based on what drawing that you gave us. We might go back and forth with you saying, okay, we probably need to tweak a little bit in your mold, or maybe we are able to do it without any tweaks. And then that mold is, that drawing is, design is analyzed for production, because these molds have to be, with laser precision. And then, so that it takes about a month's time from once you receive your first drawing to be able to deliver you the mold out of the factory.
So you'll be making this in India?
Yes.
Okay.
Yes. Importing from Europe will take 2 months just for the transportation.
What is hello? What is the maximum size of box that we can cast?
So the biggest size that we can cast is 4 meters by 2 meters by 1.35 meters. And the capacity is 4 tons. The element, the final produced element should be 4 tons or under. I'm being told that this should be the last question I should be taking. And I hope I was able, this time was worth the wait, and I've been able to do justice with your wait. Thank you, and thank you so much, and I wish you have bon appetit.